Hi there. For this video, we'll be solving more absolute value equations, but this time it's much harder than the previous video. So just to recall, in the previous video we had these three cases wherein if we have x is equal to y, and the first case is if it is less than 0, then second case if it is equal to 0, or if it is greater than 0. Now what if we don't know whether y is less than 0, equals 0, and greater than 0? How do we not know? Well, suppose if y is an algebraic expression, say x plus 2, how do we know if this is less than, equal, or greater than 0? We don't have an idea since x can range from any values. So we'll be dealing with these types of examples for this video. So starting with this one, if we have the absolute value of 3r plus 4, and this one is equal to 2 minus r. So as you can see, the right side of the equation is an algebraic expression, which can be positive or negative. So how do we solve this one? Well, the best way is to apply the cases method again. So by that I mean, we have two cases, wherein for the first case, we assume that this one out here, say this one is A is equal to this one, B. And case 2, we have A is equal to negative B. So this idea is similar to the one that we had in the last case of the previous video. So we'll use the same concept in here, since we don't know if 2 minus r out here is positive, negative, or equal to 0. So this is the safest one. So we have case 1. So for case 1, we have 3r plus 4 is equal to the positive version of the right side of the equation, which is 2 minus r. So this one is just a linear equation, so we can move this to the right side and move negative r to the left side. So we'll obtain on the left side 3r plus r equals 2 minus 4. Simplifying, we have 4r equals 2 minus 4 is negative 2. Then we can divide 4 both sides to obtain r equals negative 2 over 4, or simply negative 1/2. So let's write that one down here. And then we go on to the next case. So case 2. For case 2, we have 3r plus 4 is equal to the negative of 2 minus r. So before we can move algebraic terms from left to right side of the equation, we first distribute this negative sign out here. So we'll have 3r plus 4 equals negative 2 plus r. Then from here, we can now solve this linear equation. So we move this r to the left side of the equation, and we move this 4 to the right side of the equation. So we've got 3r minus r equals negative 2 minus 4. Simplifying, we have 2r equals negative 6. Lastly, we divide 2 both sides to obtain r is equal to negative 6 over 2 is simply negative 3. So we have these two values out here. Now note that in this one, it is more important here to check the values that we got, since extraneous solutions often appear in these types of absolute value equations. So let's check. First, at r equals negative 1/2, then we'll have 3 times negative 1/2 plus 4 equals 2 minus negative 1/2. So let's fix this one. On the left side, this simplifies to negative 3 over 2, and note that we can write 4 as 8 over 2, so we'll have the same denominator. And this one is equal to 2 plus 1/2, and we can also write 2 as 4 over 2. So we have this so far, but negative 3 over 2 plus 8 over 2 is simply 5 over 2. And 4 over 2 plus 1/2 is simply 5 over 2 as well. So indeed, this equation holds. So this one is true. So we've got r equals negative 1/2 to be a actual solution in this one. Let's check the second value of r. That is, we have r equals negative 3. So if r is equal to negative 3, we've got 3 times negative 3 plus 4 is equal to 2 minus negative 3. So on the left side, we've got 3 times negative 3 is negative 9 plus 4. And on the right side, we've got 2 minus negative 3 is simply 2 plus 3. Simplifying, we've got negative 5, and we've got on the right side 5. And this one is also true, since, again, by absolute value, we simply take the positive version of the integer inside it. So the positive version of negative 5 is simply 5. So this one is correct. And so we have our two solutions, which is r equals negative 1/2 and r equals negative 3. So that is how we solve absolute value equations with the right side of the equation being an algebraic expression, or an expression which we don't know if it is positive, negative, or equal to 0. Let's have this last example to further improve our skills on this lesson. So we have 1 minus 5x is equal to x minus 4. So again, we've got two cases. So for the first case, this one is simply 1 minus 5x equals x minus 4. So solving for this one, we simply move x to the left side and then move 1 to the right side to obtain negative 5x minus x equals negative 4 minus 1. Simplifying this, we'll have negative 6x equals negative 5. Sorry for that. Then, what we do next is we divide negative 6 to both sides of the equation to obtain x equals 5 over 6. So that is our first solution for this one. let's clear this one. Let's go on to our next case. And that is if 1 minus 5x is equal to negative x minus 4. So this one is equal to 1 minus 5x equals distributing the negative sign to the two terms, we've got negative x plus 4. Now this is just a linear equation, so we can move this to the left side and then move 1 to the right side to obtain negative 5x, which this is case 2, just to avoid confusion. We've got negative 5x plus x equals 4 minus 1. Simplifying, we've got negative 4x on the left side and 3 on the right side. Then we divide negative 4 both sides to obtain x equals negative 3 over 4. Now that we have our two values from the cases that we had, it's time to verify if these values are indeed correct. So we have check, or the checking part. So at x equals 5 over 6, we've got 1 minus 5 times 5 over 6. And this one is equal to 5 over 6 minus 4. Note that we don't really need to simplify this. Why? Because if we observe this part out here, 5 over 6 minus 4 is a negative value. Indeed, if we have 5 over 6 minus 4, we can write negative 4 as negative 24 over 6. And this simplifies to negative 19 over 6. So it is a negative value. And we know that when the right side of the equation is a negative value, while the left side is an absolute value, we know that this one is impossible, and this can never happen. Therefore, 5 over 6 is not a solution to this. How about the other one? At x equals negative 3 over 4, we'll have the absolute value of 1 minus 5 times negative 3 over 4. And this one is equal to negative 3 over 4 minus 4. Again, we don't need to simplify this one anymore, because negative 3 over 4 minus 4 is a negative value. Indeed, negative plus negative is still negative. Therefore, x equals negative 3 over 4 is not a valid solution to this one as well. And so, since both of our solutions are not valid, what can we say? We can conclude that this equation has no real solution. Or we can write it as x is an element of the empty set. So no value of x satisfy this absolute value equation. So as you can see, this is really important to check the value of x that we got, since we might have these cases wherein we'll have negative on the right side. So even though if this on the right side and on the left side might be equal, it still isn't valid if this one on the right is negative. So always remember to check the values of x in dealing with absolute value equations. So to end this one, here's an exercise that you can work on to try your skills in this lesson, or this particular absolute value equation. So we have 2 times the absolute value of h minus 4 minus 3, and this one is equal to 3 over 4 h times h minus 6. Now, although this seems complicated, it follows the same idea from a while ago. But what you will do first is move this to the right side and then divide to both sides to leave this one on the one side of the equation. Now that we are done with this, as a hint or as a preview of our next video, what we haven't tackled so far is this case. If we have, say, x plus 1 plus x plus 2 equals 3. So we haven't tackled this case wherein we have 2 absolute value equations. So stay tuned for that one. So that will be our next lesson in this absolute value equation series. So that's it, and feel free to comment down below your answers and solutions to this exercise out here, and as well as the examples if you have any questions on that. So that's it. I hope you enjoyed this one, and yep, that's all for this video.